Welcome back to Chapter 3 of our series, Crypto and Blockchain Explained Without the Hype. In this episode titled Ethereum and Smart Contracts Beyond Digital Money, we'll explore what makes Ethereum unique and how its smart contracts are transforming the way we think about transactions and agreements. So, let's dive in. Right now, more software developers are building on Ethereum than on any other crypto project. Yet most people still think it's just internet money. A trader, a game designer, and a city official could all use the same blockchain for totally different reasons. A game studio launches a fantasy world where players truly own their rare swords and armor as digital collectibles, tradable 24/7 without asking any company for permission. At the same time, a small business quietly automates payroll, paying contractors across borders in minutes. A local government pilots a land registry where property transfers settle on-chain, with rules enforced by code instead of piles of paperwork. All of these live side by side on Ethereum, powered by smart contracts that coordinate value, access, and identity. In this episode, we'll explore how these programmable agreements let money behave more like software: composable, conditional, and globally accessible. We'll look at what developers, investors, and institutions are actually building, and why this matters for the future of finance, work, and digital ownership. Instead of just moving tokens around, Ethereum lets builders wire together whole financial and non-financial systems that can talk to each other. A lending protocol can plug directly into a trading platform. An NFT marketplace can tap into the same liquidity that powers DeFi. Developers publish open-source smart contracts the way musicians release sample packs. Others can remix, extend, or combine them into new dApps without asking permission. This shared public backend is why experiments in on-chain art, microinsurance, carbon credits, and identity all keep converging on the same network. On Ethereum, sending value is only the most basic move. What really changes the game is that rules for who can do what, when, and under which conditions live on-chain and can be reused by anyone. That's why you see such a wide spectrum of apps sharing the same infrastructure, from high-speed trading bots to slow, bureaucratic processes like permit approvals. Concretely, most of this is written in Solidity, Ethereum's dominant programming language. Developers ship their logic as small, focused contracts. One might hold collateral, another might manage interest rates, another tracks ownership of a digital pass. Because everything is public, a new app can snap together existing pieces instead of rebuilding them. That's one reason Ethereum has attracted roughly 1.3 million active developers. It feels less like coding in isolation, more like adding a module to a giant shared software project. Finance is where this maturity shows first. A user can deposit into a DeFi protocol, receive a token that represents their position, and then use that token elsewhere as proof of, "I have funds locked over there." The effect is layered. Savings products sit on top of lending markets, which themselves plug into decentralized exchanges, which price assets using on-chain oracles that stream in external data like FX rates or commodity prices. Outside finance, the same toolkit powers ticketing, salary streaming, and machine-to-machine payments. A musician can release access tokens that grant entry to both a live show and an exclusive Discord. A DAO can pay contributors in real time, second by second, rather than twice a month. The analogy here is a programmable spreadsheet that anyone in the world can audit and extend, but nobody can secretly edit. None of this is free. Every operation consumes gas, paid in ETH. When demand spikes, during NFT mints, market volatility, or popular airdrops, fees can surge from negligible to painful. Upgrades like EIP 1559 made costs more predictable and burn a portion of fees, and the move to proof-of-stake slashed energy use to the scale of a small town. But raw throughput is still limited to roughly tens of transactions per second. To push beyond that, a growing share of activity is moving to rollups, lighter networks that execute many transactions off the main chain, then post compressed proofs back to Ethereum for security. In practice, your app might live on a rollup for cheap, fast interactions, while still settling to Ethereum as the neutral court of final appeal. A local coffee shop could launch on-chain memberships that unlock discounted lattes, but also double as access passes to partner venues, gyms, co-working spaces, even concerts, because each venue's contract can simply check the same digital pass. A freelance designer might set up a contract that splits every invoice automatically, part to savings, part to a tax wallet, part to a shared studio fund. A logistics firm could connect cargo sensors to a contract that releases payment only when a shipment's temperature and GPS logs prove it stayed within agreed limits. One analogy: it's like turning financial and legal workflows into modular music tracks. Bass line, drums, vocals, each written once, then remixed across countless new songs. Instead of siloed software per company or country, Ethereum-based apps can sample each other's verified records, rewards, and access rights, letting small teams orchestrate systems that once required entire IT departments and banks. As roll-ups get cheaper and real-world assets go on-chain, your brokerage statement, concert ticket, and carbon offset could sit side by side in one wallet, reacting to markets in real time. Think of a portfolio that quietly rebalances when rates move, tips your favorite creator after each stream, and funds a reforestation pool when your energy bill spikes. No forms, no weights, just rules you set once and let run across borders and platforms. We're still early in treating code as a shared financial language. Next comes quieter, background uses: rent that adjusts with inflation data, family budgets that release pocket money when chores are logged, cross-border co-ops that pay members instantly. As interfaces improve, the question shifts from "what is this?" to "which rules do you want your money to follow?" Try this experiment. Pick one real-world process you use, like renting a parking spot, splitting utility bills with roommates, or tracking a subscription, and recreate it as a simple Ethereum smart contract using a no-code tool like Remix with example code from the episode's show notes or docs. Deploy it to a testnet, for example Sepolia, then actually use it for a week. Trigger the contract the way you would in real life, for example, send a mock rent payment, log bill splits, or simulate subscription renewals. Track what worked and what felt clunky. Where did automation help? Where did it miss nuance? And what information or trust assumptions did you still need off-chain? This was Owl Up, your daily step forward. This series continues with more chapters on owlup.co. Visit owlup.co to access the complete course and continue your learning journey. See you there!